By 2015, Earth will no longer be able to support the growth of human civilization. This is not a warning, it is a countdown. Mankind was born on Earth, but it was never meant to stay. Most people assume Earth has centuries left to figure this out, that space travel is a luxury for billionaires, not a necessity for the species. But the math already says otherwise. Resource collapse, climate instability, and a single asteroid are all it would take to end 300,000 years of human history in an afternoon. So, how does a species with no experience living off-world begin building a second home? Where do you even start when nowhere else in the solar system has breathable air? How much of this can actually be done from Earth, and how much has to happen somewhere else entirely? What comes first, the ship, the base, or the people willing to leave? Every stage of this plan is based on real proposed engineering: orbital shipyards, closed-loop life support, nuclear propulsion already in development today. Here is the 130-year roadmap humanity will follow, starting now on Earth. The first fully reusable heavy-lift rockets begin flying weekly instead of yearly. A rocket that once cost a nation's space budget now costs less than a domestic airliner. For the first time in history, mass isn't the problem. Cost is solved. Somewhere in Texas, an engineer watches a booster land upright for the 100th time and stops taking notes. It's routine now. The real work is only just beginning. Construction begins on the first permanent orbital shipyard, a skeleton of girders assembled by robotic arms, with no roof, no gravity, and no room for error. Everything sent here first has to survive the trip: steel, water, and the first crew of 12 who will live in orbit for 2-year rotations. One of them writes home that the hardest part isn't the work, it's that Earth, from here, looks small enough to hide behind a thumb. Why not build everything from Earth? Because Earth's gravity well is the single most expensive obstacle in the entire plan. Every kilogram lifted off the surface burns fuel that could instead be spent going further. The Moon has 1/6 the gravity and no atmosphere to fight through. It becomes the staging ground. The first lunar mining outposts begin extracting water ice from permanently shadowed craters. Water that will become drinking water, breathable oxygen, and rocket fuel without ever needing to leave Earth's orbit for resupply. The first orbital shipyard at Mars comes online, built from materials mined in the asteroid belt rather than shipped from Earth. This is the real turning point. The moment humanity stops building spacecraft from Earth and starts building them near Earth's future destination instead. A supply chain now stretches from lunar ice mines to Martian shipyards, 3 planets deep, and not 1 gram of it depends on a single planet's surface anymore. The first permanent Mars settlement passes 10,000 residents. Children are born who will never see Earth's sky. It is here, using Martian metals and asteroid belt water, that construction begins on something no civilization has ever attempted. A ship built not to visit another world, but to carry a self-sustaining human population across the gap between stars. The ship is given a name before its hull is even sealed. a tradition carried over from the first orbital stations decades earlier. Its designers call it the Helianthus, after the sunflower that always turns to face the light. 30 years of assembly lie ahead. Somewhere on the shipyard floor, a foreman who was born on Mars runs her hand along an unfinished bulkhead and realizes she is touching the walls of humanity's first true generation ship. By 2130, humanity is no longer asking whether it's possible to leave the solar system, only how fast the Helianthus can be finished and who will be alive to see it launch. But before any of that can happen, there is still one closer world to master first, the one just 3 days from home, where the very first permanent human base is about to mark its 10,000th day.